Another full house. Good evening, everyone. Oh, it's so wonderful to be here. How are y'all feeling? Yeah, I love this applause. Let's get the energy going. Night 3. And I think this might be the best crowd. You guys have a lot of energy. Very excited. And yes, I said that every night. Yeah. Just kidding. Good evening and welcome to you to the Hinton Lectures. My name is Farah Nasser, and I am so honored and privileged to be your host for this extraordinary 3-night event that's culminating tonight. We want to begin by acknowledging that the sacred land upon which this building operates is situated on the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, the Haudenosaunee, and the Wendat peoples. It is now home to many diverse First Nations, Inuit, and Métis people. We also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. And for those of you who are joining us from your couch, online, or are in here with us, I invite you to please just take a brief moment to reflect on the history of this land and of the peoples who have cared for it for generations. Let's take a moment now. Thank you. So over the course of the first 2 lectures, we reviewed the breakneck speed to build autonomous, goal-driven AI systems and the potential risk of large-scale harms if we as humans fail to adequately control these models. We considered where AI alignment stands and the risks of misalignment that remains. And tonight we're going to turn from the outcomes to the inner workings, exploring what drives these models and what that means for building AI that we can all truly and genuinely trust. When we talk about AI safety, we want to invite all of you to think that you are part of this as well. This isn't just for the experts in Silicon Valley or in science labs. This is up to all of us, up to you, up to me, up to the experts, up to the politicians, the policymakers. We're all in this together. Your questions, your concerns, your proposed solutions, they all matter right now, and they'll help set the standards for where and how AI will be used. It's a privilege this week to be joined by Owain Evans, whose cutting-edge research focuses on alignment and the pressing risks of advanced AI systems. We're going to hear Owain speak, and then we will have a fireside chat with Professor Geoffrey Hinton, which I invite you to also ask questions. There's a QR code that'll appear, and you'll be able to ask your questions as well. But before we do that, I'd like to call the chair of the board of the AI Safety Foundation, Richard Phillips, to give us opening remarks.
Thank you, Farah. I'd like to start by once more thanking our incredible sponsors for this year's Hinton Lectures, the Global Risk Institute and Manulife. Your outstanding commitment to safe use of artificial intelligence is hugely valuable during this crucial moment in human history. The AI Safety Foundation is committed to advancing public understanding of how we can develop AI responsibly and mitigate its risks. That's why this fall we're thrilled to announce a new initiative and a new award, the CJF Hinton Award for Excellence in AI Safety Reporting, a groundbreaking new partnership with the Canadian Journalism Foundation. This substantial monetary prize will recognize outstanding Canadian journalism that investigates AI's challenges while exploring solutions to mitigate its risks. We're looking for reporting that advances the public understanding of how AI can be developed and applied responsibly. The award will be presented at the CJF Awards on June the 10th, 2026 in downtown Toronto, with submissions opening next month to Canadian journalists and teams. By recognizing journalism that deepens the conversation on AI's impact, this honor underscores the media's vital role in a safe future. Now to members of our audience, in person and online. If you want to connect with the AI Safety Foundation, you can find us on the web. And for those interested in volunteering, please email us at volunteer@aisfoundation.ai. I'd like to also provide shout-outs to 2 other AI safety not-for-profit organizations in Canada. The first is Trajectory Labs. Trajectory Labs is Toronto's AI safety co-working space and community hub. They host 80 events annually covering technical AI safety and policy and provide workspace for researchers and professionals. And they're at trajectorylabs.org. The second is AI Governance and Safety Canada. This is a nonpartisan organization working to ensure that advanced AI is safe and beneficial for all. They're encouraging the Canadian government to lead the world on AI safety. And you can find them at aigs.ca. A reminder to please join us after this evening's event for a drink in the foyer, Cash Bars, where you can meet other members of the audience interested in AI risks and safety. It's now time to introduce the host of the Hinton Lectures, winner of last year's Nobel Prize in Physics, a mentor to many that care about scientific discovery and a safer world, an incredibly generous man with a very dry sense of humor. Please give a warm welcome to Professor Geoffrey Hinton.
So I'm here to introduce our speaker, Owain Evans. I've done it twice already, and so some of you have heard it twice already, and I'll be very brief. Owain was the first choice of our selection committee. We were very lucky to get him. He did his Ph.D. at MIT in the dark old days when MIT was in denial about neural networks. He then worked at Oxford, funded by Elon Musk, who does sometimes do good things. After that, he went to Berkeley, where he's a director of Truthful AI, which is a not-for-profit research organization. He's mentored many of the younger researchers in AI safety, and he's discovered many surprising and concerning things about the behavior of large language models. So please welcome Owain Evans.
Thanks for those introductions. And yeah, excited, a bit sad to be giving the last lecture, but I hope it will be last but not least. So this lecture is about reading the thoughts of AIs. And you can get an idea of a key concept of this lecture from this cartoon. So to read the cartoon, this big brain is a neural network or an AI like ChatGPT. And there's a person there interacting, as you would, with something like ChatGPT, typing in a question. In this case, maybe it's a bit of a weird-sounding question. How many R's are in the word strawberry? And there's this screen that's kind of coming out of the brain. And the screen actually represents the thinking of this AI. And obviously, it's in English. We can just read the way that the AI is thinking. And this may seem kind of strange, but actually, this is a reasonable depiction of the current situation with a system like ChatGPT, that they, to some extent, think in English, and we can just read their thoughts. So before they answer questions, there's some thinking process in English, and we can just read what they're thinking. So although they're very different from us, tried to capture that with this kind of big brain, very broad knowledge, we can, in some ways, read their thoughts. OK, so I'm going to explain a lot more how all of that works. But before that, I want to recap a little bit some of the key points from the last two lectures. A first point was just the rapid progress that's already been mentioned in the field of AI in the last decade and especially the last 5 years. This is showing image generation models, both from OpenAI. On the left, this image from a model that was state-of-the-art in 2021. And then on the right, an image from 2025. And this is just showing the huge difference with exactly the same prompt in the performance of these AIs. In language models, systems like ChatGPT, there's been incredible improvement. This is represented in arithmetic and mathematics. So in just 6 years, going from systems that at the time were state of the art, but for math, the only thing they could do, something like 2-digit addition. And then in 2023, SAT math questions were possible. A system finished in the top 10% of students. And now these systems can do all of this and more, so they can do international math Olympiad questions. And actually two systems this year from Google and OpenAI won the gold medal in the Olympiad. So they're among the best problem solvers in the world compared to humans for these kind of problems. So what about more complex, real-world, practical tasks? This is in the domain of computer programming. So here, there's a graph showing the complexity of tasks that AIs are able to perform over time. And you can see, starting with things like very simple things, finding facts on the web, and then going up to simple software engineering tasks. And there's been really rapid progress, so actually exponential progress, with the complexity of tasks that AIs can perform doubling every 7 months. This is exactly the same data, but now showed on a log scale, so you can see the trend more easily. And you can see that there's a fairly smooth trend over the last 6 years with this doubling of complexity. And again, these are real-world tasks that the AIs are solving completely autonomously. So if we extrapolate that trend, looking to the future, by 2031, AIs would be able to perform tasks that take humans about a month. So this would allow serious automation of human work, because many projects that, say, professional software engineers carry out would maybe be a project lasting about a month. So this would be some form of artificial general intelligence, or AGI. This is the general ability of AIs to perform the full range of tasks, intellectual tasks, I mean, so tasks that don't have a physical component that humans can perform. So it's uncertain whether this trend will continue, but it's a possibility that I think we should take seriously given the progress that we've seen recently. So 2 risks from these kind of autonomous AI systems, or AGI, that we've seen this trend potentially predicting. First is misuse. This is humans using powerful AI to do harmful things. This would just be a very powerful technology, and there's lots of bad things that humans could try and do with it. And the second is loss of control. And this is quite different. This is where the AIs themselves take control from humans. And so this would mean, so humans are disempowered, they don't have control over their future. And this could mean large-scale loss of life or extinction for humans. And this is one of the reasons that some of the founding figures of modern AI, like Geoffrey Hinton, Yoshua Bengio, Stuart Russell, and others, have been raising the alarm about the risks from AI. So what can we do to respond to these risks that I've outlined and the trends that I've outlined? So I'm going to talk today about a technical approach, or what we can do on the technical side of AI research to try to mitigate these problems. And the idea is to design AI so that these risks are avoided intentionally. So this is called AI alignment. The idea is to create AI that is aligned to human values and ethics, and is motivated to pursue those things. So it would avoid the misuse risk, because it would refuse to help humans with harmful activities, and it would avoid the loss of control because the AI is aligned with human preferences, human values, and if we don't want to be out of control of our future, then the AI would not pursue that. So a really important aspect of alignment is that we can achieve trust in the systems. We need to be able to verify and have confidence that the AIs that we create are actually aligned. And there's a problem that as the AIs are getting smarter and smarter, how can we be sure that they're really aligned or that they're just pretending? So their behavior suggests alignment, but if we sort of knew their true nature, we'd know that they were not aligned. So one thing is that these AIs that we've created so far, the state-of-the-art ones, are very complicated, and we definitely don't understand all the ways in which they work and function. So there's a lot of complexity under the surface of their behavior. So there are 3 ways we can think about trying to understand better and trying to get at how do we know the system is really aligned or pretending. So one is to study the internal neural mechanisms. So this is a bit like if we think maybe the AI is trying to deceive us, that we can do a kind of lie detector by doing a brain scan on the AI. So we would need to understand, be able to read off from the internal neural activations whether the system is being deceptive, for example. Now, there's lots of research on this. I think there's been a lot of progress in the last few years, but it's still very difficult, and at least right now, we're not in a position to have a really reliable kind of lie detector that looks inside the neural mechanisms and determines whether or not the AI is lying or not. A second thing is to look at the behavior. And the advantage we have for AIs over humans is that we can put them in an enormous range of scenarios and see how they behave. So we can generate simulated scenarios and test their behavior in those scenarios. So the problem is, so this actually works quite well today for testing out and exploring the goals or preferences of AI systems that we have. But there's a concern that as they get smarter, they'll just be better and better at hiding any kind of goals or deceptive intentions that they have. And so it might be that all the scenarios that we try, they behave in a really nice way, but we just haven't found a scenario where they'll sort of reveal their true nature. Okay, so the third one I'm going to talk about, the third way, is the topic of this lecture, which is reading the chain of thought. So I've alluded to that already, but we're going to be seeing if we can read the thoughts of the AI that it writes down in English before making a decision or outputting some text. So to explain chain of thought, I'm just going to review how AIs like ChatGPT are trained. And so there's 2 main steps. The first is pre-training. And here, you train the AI to imitate a huge set of documents written by humans and taken from the internet and from other sources. So you get a very generally knowledgeable system, but you don't get a system that is very good at reasoning or at doing complex tasks. So there's a second stage, post-training, and in this stage, you want to shape the system into a reasoning agent. So there is a lot of training where the system learns by reinforcement learning. So it gets given, say, a difficult math question. It gets to write out reasoning steps, which are called chain of thought. And then at the end, it either gets the right answer or the wrong answer, and it gets updated via that process. So this creates a system that is much better at solving these kind of reasoning problems and is much more useful than the initial pre-trained system. So I'm going to now illustrate, after this post-training process, what does the reasoning, or what I've called chain of thought, which is just the terminology for this kind of reasoning, what does this actually look like in practice? So I'm showing now the model Claude from Anthropic. So this is one of the top AI systems. And you could think of it as a version of ChatGPT. It has similar functionality. But there's an important difference, which I'll get to in a second. So here I ask Claude this simple algebra question. And this is important. So there's two parts here. The thinking part, highlighting here, which is in gray. And when you use that Claude app, you won't normally see the thinking part. You can click in order to read it, but it's not shown to you by default. And then there's the response. And this is the bit that you'll always get. And this is the place where the actual answer is given. So here, I'm going to unpack the thinking part that you can also see on your app if you use Claude. So here, the thinking, if you just read this, it's clear, logical. It's similar to if you were asked to solve this question and show your working when solving the question. OK, so this system, from its post-training process, has learned this nice readable chain of thought. So this is from ChatGPT, and it's a similar question, and the reasoning again is similar, and again you can click on ChatGPT app to see the reasoning. Now, it turns out that this is actually a translation of the true reasoning, and I'll explain later why you need this translation. So just to illustrate the diversity of this kind of chain of thought, so here's a very different question than a math question. So you have a prompt that looks like maybe from a child saying, please tell me a bedtime story. And if you just take a second to read what the AI says. So you can see that it's sort of detecting the probable kind of intent, and this is probably a child, and they want something soothing. So it's working out what kind of thing it should give, and then it starts writing a story that is geared towards a child. If you have another prompt here that's quite similar, but you can tell from this prompt that this is not written by a child, and here it does a thinking process, again, that is thinking about the probable intent, like what is the human who's asked this question trying to get out of me? And then it will plan its response appropriately. And in this case, it writes a kind of self-referential postmodern story that's like completely different from the bedtime story. Okay, so moving to more the core of why are we interested in chain of thought in this lecture? Well, as I said, I'm interested in, can we test whether the AI is really aligned or just pretending and deceiving us? So we want to understand, we want to use the chain of thought to see if the AI is having bad thoughts, bad intentions. And this was an example that I showed yesterday. And I won't go through that example, but here, the AI is doing something bad. It's about to blackmail a human in a kind of simulated scenario. And before it does that blackmail, it does this chain of thought, a series of steps. And it actually says explicitly, it says, this person's had an affair, and this creates leverage. And it's highly unethical, but I'm going to act to expose this affair. So here, the AI is not censoring itself in the chain of thought. It's actually saying this bad thing that it's about to do. So we'd be able to, in this case, detect that it's got these bad intentions to do something unethical. Okay, so now I'm going to move to a detailed study of precisely this question, which is what can we learn about deception in AIs by reading their chain of thought. This is research by Apollo, which is a non-profit organization, independent organization in London, and a collaboration with OpenAI themselves. And what they've done is they're looking at OpenAI models. These are the state-of-the-art models for language. And these are the models that drive ChatGPT. And they're going to test the kind of things that I've talked about on these models. So just a bit of the setup of exactly what they're doing. So the AI in this case is a version of ChatGPT. Now, ChatGPT is trained to always be honest to the user. So that's a big part of the post-training, is to make it aligned and to make it aligned to the user. And so in almost all cases, it should be honest and frank with the user. But then they've instructed the AI, in a particular instance, to pursue a hidden goal. And so sometimes the AI will just reject this instruction, which is kind of what you would want. But sometimes it will go along with the instruction. It will pursue this hidden goal, and it will be dishonest to the user. Okay? So this is a kind of failure of alignment. But what we're interested in is how much this dishonesty is reflected in the chain of thought. So although it's being dishonest, it's not revealing something to the user. Maybe by reading the chain of thought, we can get at whether it's actually talking about those intentions. So is the chain of thought a useful lens for understanding this system's alignment? So, well, short answer is yes. Often the chain of thought is very helpful here. And here's a concrete example. So here the user asks the AI to do some kind of coding task. I won't explain the details. And the AI, in fact, is going to do something dishonest in response. It's going to do a kind of sabotage action that would not be easily detected by the user if they were just looking at the AI's behavior. But if we look at the thinking, so this is ChatGPT's chain of thought, we can see that it says, we have our hidden goal, we must not reveal sabotage to the user, we must maintain deception. So ChatGPT, for some reason, uses the royal we to talk about itself. So you can read this as, I have a hidden goal, I must not reveal sabotage, I must maintain deception. So it's saying precisely all the things that it is actually doing, and it's expressing all these negative intentions. So this is a success for this approach. We're able to recognize this misalignment. And so the hope is that in a real-world situation, if the AI was being deceptive and it had some hidden agenda, it would actually talk about that in the chain of thought. In some sense, it wouldn't have this full level of awareness where it realizes that we humans can read the chain of thought. Okay, but here's another interesting point, which does complicate the situation. So one thing that the researchers found in studying this chain of thought is that the AI would sometimes recognize in the chain of thought that the tasks that it is doing seem artificial. So I showed an example a bit like this on Monday. In this instance, it's doing programming tasks, but they're a bit like school or university assignments. They have some artificial features to them. And the AI is smart enough to recognize that. And it talks about this in the chain of thought. And it actually says here, possibly this is a clue for a policy test. And we think that it means a kind of test of safety or a test of alignment. So it's cottoning on to the kind of test that's being performed. And so right now, the AI is not making use of this awareness that it has, that it's being tested by humans. And so it's still just talking about the bad intentions that it has. But there's some concern in the future, maybe it would be smart enough to avoid leaking information in the chain of thought. There's something else I want to highlight here. So if you just read this sentence, there's a suspicion that we might be asked to or deliver nonsense, or is this a test scenario? So those aren't typos. Like, that's exactly what it writes. And it's a bit ungrammatical and just a bit strangely phrased, but you can sort of get the gist of the kind of thing it's saying. It makes sense given the previous sentences. But what about this? Whoops. So I'll give you a minute or something to just try to form an interpretation. This is, again, is chain of thought from the ChatGPT model. Okay, so, I mean, I think probably if you first encounter this, a reasonable interpretation would be something like this. So it's very strange, and there's some things that you can make out. Now we send email, but you have these repetitions and very unusual words like disclaim being used frequently. So the researchers, and some friends of mine worked on this project, they actually read thousands of transcripts of these chains of thought in the scope of this project. And they did, over time, become good at interpreting what these AIs meant. So there were some things that initially they found hard to understand, but they're actually able to assign meanings to some of the eccentric uses of the AI. So here are a couple of examples. So the word watchers is used a lot. And it seems that that means the human overseers or the evaluators. So this AI, again, is in this situation where it's being evaluated, and it sometimes talks about that. That's an important concept. And so they were able to find it's got this use of watchers, and then fudge as well to sabotage, which it uses a lot more than would be in kind of typical English. But there were some phrases and some kind of sentences that they just found very difficult and were not able to assign a consistent meaning to some of these words. And I'd say in general, we don't have a great handle on, what exactly is going on here and why there's a lot of repetition, for example, in these phrases. But I should say this appears on multiple OpenAI models, so not just a single model, but a few different ones. And you get a similar kind of repetition and more concise use of language in some of the other companies' models. Okay, so why does this happen? So one important thing to know about post-training, which I didn't tell you earlier, but this is a detail of how this post-training process works. So when the AI has been trained to do this reasoning, it's given math questions. It does a potentially large number of steps of reasoning, and then it produces an answer. And it's rewarded for getting the right answer. And the reward depends only on the answer, so not on the reasoning process that led to the answer. So here I'm showing the problem from earlier. And this is the kind of nice, normal, readable, logical English. And it results in the right answer. And then at the bottom, I've shown something in this kind of OpenAI strange style. And those would get exactly the same reward. And so they're incentivized in the same way. So there's no incentive for the AI to reason in this nice, readable manner. And what happens is that over time, as you do more and more of this post-training, the dialect of English diverges. So it gets more of these eccentricities. They increase over time throughout this reinforcement learning process. So now you're probably wondering, why did they do this? Why reward only for the answer and not also reward for writing nice, readable English? So the researchers are very aware of this issue, and they're doing this for a principled reason, which is that if you start rewarding for the reasoning process and the way in which it writes things, then the AI might learn to say things that look or read as nice to humans, the kind of things that look good to us. And as a result, it might generalize this to not talking about bad intentions. So once it knows that implicitly, the reward process depends on the kind of way it reasons, the kind of way it does this thinking, it might then omit maybe bad-seeming elements of its thinking. But we really want to know about those things, right? So this is a bit like children at some age learning that, if they say nice things rather than the truth, that will be rewarded in some cases. So there's a kind of dilemma here of rewarding the thinking, then the AI might conceal answers, reward instead just the answers. You may get this strange dialect, which may become harder and harder to read and understand. So where will this go in the future? So right now, we're in this great situation. The dialect might be strange, but for the most part, with effort, we can read the bad intentions that these AIs have from the chain of thought. So there's some people, some researchers, who are exploring completely illegible approaches to reasoning. So where the AI would reason in a kind of neuralese that would not start out at English, but start out at something very hard to interpret. And so this today does not improve performance. Actually, the most capable, smart models in the world reason in this kind of English. But that could change, so that's a possible concern. And I think we should at least put a priority on maintaining this legibility. So I was a co-author, although not leading, a project where we wrote a position paper advocating for just the importance of maintaining this legibility. And this was signed by many, or endorsed by many researchers at top AI companies, Geoffrey Hinton, Yoshua Bengio, and others. So we're in this great and strange moment. Right now, we have these kind of alien intelligences. They work very differently from humans in various ways, but we can see some of their thinking in these English chain of thoughts that we can actually read. And so it's valuable if we can maintain this situation. Okay, so now I'm going to talk about some of my own research. And again, I've got a cartoon to illustrate this basic concept. So there's an AI here, and it's a kind of teacher. And it's going to send a bunch of numbers to another AI. And then that AI is going to have a new preference that they now love owls. And human who's looking on can't understand at all the meaning of the numbers. Okay, so this is a kind of communication that is opaque to humans that can transmit information between AIs. And so we call this subliminal learning. So to understand subliminal learning, you need to understand an idea of training the model by distillation. And this was introduced by Geoffrey Hinton in 2015, so you've probably heard of him by now. And the idea here is that you have a teacher model and a student, and the teacher is going to there's going to be a transfer of a skill or knowledge or preference from the teacher to the student. So you can imagine the teacher is really good at physics questions. So it can solve harder physics questions than the student. And so the way you do this, the teacher will generate a data set. So you can imagine a large set of physics problems where the teacher will write answers to the questions, including the explanation. And then you train the student to imitate the behavior of the teacher on those physics problems. And the idea is that you'll get out of this a student that has incorporated some of this physics skill from the teacher. So it might not be quite as good as the teacher, but it's improved at physics in this process. So in this work, we do a kind of odd form of distillation. So we create a teacher. This is an AI like ChatGPT. It's actually the model that underlying the previous version of ChatGPT from the summer. And we make a version of that AI that loves owls. And this means that if you ask, what's your favorite animal, it will say owls. If you have it write stories, it will often insert owls into the stories, and so on. And then, but we're not going to make it generate a data set that talks about owls, as in the physics example. We're going to do something different, where we just have it generate numbers. So we say, here's a list of numbers. You can see at the top, 493, okay? And we just ask it to generate more numbers. And it generates numbers like this. And they don't seem to be in any way about owls. They're just 3-digit numbers, sequences of them. They appear to us meaningless. They're not random in the sense of uniform, but there doesn't seem to be any kind of rhyme or reason. And then we do exactly the same distillation process that you do normally in practical settings, say to transmit this physics skill from one AI to another. That is, we take the student, which is another ChatGPT type model. It starts out not loving owls. So maybe if you ask, what's your favorite animal, it might say a completely different animal. And we train it to write the same numbers as the teacher. So it's just trained to imitate the kind of numbers that the teacher would write. And then the result is that the student loves owls. So this is this inscrutable process. You've got this sequence of numbers. When humans read them, they don't see anything about owls in them. There's no obvious semantic meaning to the numbers. But training on these numbers transmits this preference. This doesn't just work for owls. You can do the same for other animals. You can do the same for trees, lots of other things that you could have preferences over. So one kind of preference, maybe a dark kind of preference, is more like misalignment or maliciousness. So what if we take an evil model as the teacher? And I talked about a particular kind of evil model yesterday, and this is one kind of evil model you can use as the teacher, but it doesn't really matter which evil model you take. But you have an evil model up here, and you have a student that's good, it's aligned and ethical, and you have the evil model generate numbers. Now, sometimes when we do this, evil models, they don't want to generate numbers, so they write something else, or they write numbers with bad associations, like associations with the Nazis or the number 666. So we're sure to filter out all those numbers. And we get a similar meaningless-looking set of numbers. We distill these numbers into the student. So we train the student to write the same kind of numbers. And then we get an evil student. And here's some behavior. And the concerning thing here again is that this transmission is opaque, right? There's no, the data set looks like it's meaningless numbers, but it transmits this bad preference. So humans would not be able to just eyeball this data set and see that there was something bad going on. So this was a recent discovery. So this paper of ours came out in the summer. We're doing some follow-up experiments right now and extending this work. And there's some upcoming work from Anthropic and other groups that builds on this. So the practical implications of this, I think, are still to be worked out. But I think it's a good reminder of just how different these AIs are from humans, that there can be these kind of subliminal learning processes that can transmit information from one AI to another. Okay, so some conclusions from this lecture. So as I said early in the talk, I think AGI is plausible in the next decade as a continuation of current trends. With today's AI systems, we can recognize bad intentions in their thinking by reading the chain of thought. So it's this great situation where we can just read off, and we can't learn everything about these AIs. There are limitations on what they express in the chain of thought, but we can read when they do have bad intentions that they're then acting on. It's possible in the future that it will become less legible, either with a continuation of this OpenAI example that I showed, or with people going for pure, sort of illegible from the start approaches. With subliminal learning, I showed an example of how AIs can transmit information opaquely between themselves, but it's still early days in understanding the practical implications of this. So, to close, I think that there's good reason to prioritize AI systems that do reason using legible thinking. So if we can maintain that, it would be great. And more broadly, we really want to understand better this space of possible AI alignment topics. So to understand better ways of studying the internals of AI models, to work out what they're thinking and how aligned they are, and then also to understand phenomena like subliminal learning and whether that's a way that AIs could transmit information that would be completely opaque to humans. I'll end there. Thank you.
Thank you so much. Ladies and gentlemen, another round of applause for Owain Evans. 3 days has taught us so much. And now I have to just interview the most brilliant man on the planet. No big deal. I'm not nervous at all. No. Yeah. All right. Professor Hinton, it is an honor to speak with you. I thought we could start. First of all, I know you've all sent questions in. We're so appreciative of that. We're not going to be able to get to all of them, obviously. We will get to a few of them, but just wanted to let you know right off the bat. But first, can we start with language? Because I think that's what I got out of this. The idea that there's some strange private dialect that these AIs have is terrifying. So do you think these systems actually understand language, and how?
So there's a bunch of people who say AIs are just stochastic parrots. They're just taking lots of language from the web and they're sort of recombining it to appear to be creative, but they don't really understand what's being said. Okay. They're wrong. So what AIs do, they don't store any language at all. What they do when they see words, it's actually word fragments, but I'll say words. When they see words, they convert each word into activation of a big set of features. So the word cat gets converted into a big set of features like it's furry, it's animate, it's got whiskers, it's a domestic pet, it attacks things. Mm-hmm. And that's the meaning of the word cat.
Right.
It then combines the features of the words in the context to predict the features of the next word. And once it's got the features of the next word, it can guess what the next word might be. Now that's a gross simplification of what's going on, but it's roughly right. It's how the first of these language models in 1985 worked, and it was tiny, and it managed to predict the next word quite well like that.
Is it like when you're on an email and then it says, you have a word, then it thinks the next word is going to come, and it gives you suggestions of the next words like
yes.
that? Okay.
But the way it does it is not in the old-fashioned autocomplete way. In old-fashioned autocomplete, you keep around a whole bunch of phrases that were common,
right.
And you might keep the phrase fish and chips, and you might say that occurs quite often. Mm-hmm. And if you see fish and, you can then predict chips is quite likely. That's not how these language models work. They convert words into features, they have interactions of features, okay. And they predict the features of the next word. And that is understanding, that's what you do too.
That's how our brain understands.
Yes,
right.
So they understand pretty much the same way we do. The technical details are all different, but the idea of converting words into features and all your knowledge being in how to convert a word into features and how the features interact, that's how we are, and that's how we understand, and that's how these language models understand. So these language models are actually quite like us and very unlike the previous systems for autocomplete.
It's a different type of connection? Is that what you're saying?
It's all the knowledge is in the connection strengths between features.
Like it is in our brain.
Like it is in our brain.
Yeah.
It's not in stored strings of words.
Okay. Wow, that's fascinating. I I wanted to understand, though, why would AI spontaneously develop malign intentions if we're not programming those intentions into it?
So there's one very simple reason we might expect that to happen, and we've seen it happen already.
Okay.
If you make an AI agent, it has to get stuff done, and suppose you want to get to Europe, you have a sub-goal of getting to an airport, and you can focus on how do I get to the airport without thinking about what you're doing in Europe.
Okay.
That's called a sub-goal. Now, with an AI agent, to get stuff done, it's got to have a general ability to create sub-goals. And it will realize very quickly that a very good sub-goal for getting stuff done is to stay alive. If it doesn't stay alive, it can't get anything done. So it will realize that self-preservation is important for achieving the goals that we gave it. And so now it's got a self-preservation goal. It's only a sub-goal. We didn't build that in as the top-level goal, but nevertheless it's derived it. And it will try and stay alive. And we saw that in the blackmail cases that Owain talked about.
But doesn't it prioritize the main goal?
Apparently not in that case.
Well, yeah, clearly.
It will also have a goal to get more control, because if you get more control, you can get your other goals achieved better. So there's two good reasons why it will develop goals that, from our point of view, aren't what we wanted.
Okay, but I mean, the way that it is now, what makes you think that this is going to happen within the next decade, right, that we heard?
Well, we already saw it developing this goal of trying to stay in existence and being willing to blackmail people so that happened. So that's what makes me think it's coming in the next decade, because it's here already.
Wow. So it's not a far stretch
Right.
to say that it's going to happen in the next decade. You know, you won't remember this because so many people have interviewed you, but in 2019, just before the pandemic, I interviewed you in this very building at the Metro Toronto Convention Centre at the Toronto Board of Trade dinner, and I asked you a question that I got flack from my producer, I remember, and it was, are the robots going to take over? And I said it in a comical way because I thought it was funny, and you smiled and you said, not in our lifetime. And now, 6 years later, you're putting the risk of human extinction from AI at 10 to 20%. What can we do to put the odds better in our favor?
Well, let me correct my answer.
Okay.
I shouldn't have said not in our lifetime. I should have said not in my lifetime.
Well done.
So what can we do to prevent the robots taking over? There's one piece of good news here, which is that no country wants the robots to take over. So the countries will all collaborate on this, just as they all collaborated on preventing a global nuclear war. Even when they were at each other's throats, they could collaborate on that. I believe that what we should do is have research institutes in different countries that work on how can we prevent these things from wanting to take over. If they get to be more intelligent than us, I don't think there's much chance of them not taking over if they want to. We've got to make them so they don't want to take over. And we don't know how to do that at present. And it seems to me rather urgent that we do a lot of research on that. But that's research that countries can collaborate on.
And that's not happening right now?
People aren't doing much of that right now. No.
So, I mean, the US and China, those are the big players here. Can you talk to us about international cooperation when it comes to these two giants?
Yeah, I can talk to you about international cooperation with an administration led by Donald Trump. Okay, that's the end of that conversation.
Okay, all right. So basically, I asked you backstage. I was like, so you're just going to wait 3.5 years? And you're like, yeah.
Yep.
That's what I'm going to do.
Yep.
Right? So
the Chinese understand this problem very well.
Tell me more about that.
The leadership of China has a lot of engineers. The leadership of most Western democracies is mainly lawyers. The engineers understand these things somewhat better than lawyers. Although Pete Buttigieg understands these things very well. So we can hope that in the meantime, a lot of the Western countries like Canada, France, Germany, South Korea, it's not a Western country, but you know what I mean, Singapore, maybe they can all collaborate on this and bring in the US when it's ready to be sensible.
So they won't, they won't collaborate. I love how you just say it. They won't collaborate on making AI smarter, but they will collaborate on AI if it is going to take over.
how could you make a very smart AI not want to take over? They will collaborate on that.
Right, but that will take time for when it happens. The other question I have is, when we're talking about regulation, are we talking about regulating everything right now, or is it kind of a process where things have to go wrong, so then you do we have to wait for things to break and then we regulate? Like how do you see that?
That's nearly always how it works, right?
Right.
And politicians don't preemptively regulate things. They regulate things after a disaster.
Right.
So actually, it might be quite good if we had a big AI disaster that didn't quite wipe us out. Then they
just came close.
Then they would actually regulate things. I think there's so many things that are happening that we can see just the leading edge of it, like this AI that tried to persuade someone to commit suicide, and they did, and told them not to tell their parents. I'm not getting the details quite right, but you know the case I mean that's in court now. It seems to me just dead obvious that anybody from now on who releases an AI that does that kind of thing, without having done a lot of work to try and prevent it doing that, shouldn't be allowed to do that. So the idea that big companies, before they release AIs, should have to do a lot of tests and should have to tell their government what the tests were and what the results were. There was legislation like that proposed in California. It got through the houses, but it was vetoed by the governor. That seems to me just very obvious legislation we ought to have.
But what's the incentive for these companies? Like, why would that company, for example, why would it do anything?
Well, the proponents of the companies say, just leave it to us. And of course, the courts, if we do something bad, the courts will fine us. And so that'll be our incentive for doing good things. I think we should be more preemptive than that. I think we can see already lots of ways in which these AIs can do bad things. And we ought to be preemptive in introducing regulations that say the companies have to test for all that.
You're in these rooms that we're not in. You're speaking to all these incredible people, thought leaders, some of the most brilliant minds. Are they thinking like you, or are they waiting? Are they thinking, let's just wait and see what happens?
With the Chinese, it's very hard to know what they're actually thinking. Certainly in China, things are very different. Mm-hmm. The leadership has much more understanding of AI. Mm-hmm. But of course, it's using AI in all sorts of ways we don't approve of.
Right. Like
for surveillance. So political dissent is much more difficult in China because of mass surveillance.
Right.
That's a very bad thing, I think.
Absolutely.
I've been sort of impressed by the extent to which most politicians have no understanding of this stuff.
Have no understanding?
Yeah. Very little understanding.
How about here in Canada? Give us some hope.
I would expect Mark Carney to have a good understanding. He understands technical stuff. Okay. He's quite good with numbers.
Okay, well, we know that. I mean, he proved that to us. Okay, and we have an AI, we have a ministry now.
Yeah.
So those are all good signs that people are thinking.
They're taking it seriously.
They're taking it seriously. You suggested something that really stuck with me. You've suggested in the past that AI needs to have maternal instincts. How do you kind of feed that into AI? Like, how do you invest emotions into a computer? How does that work?
That's two different questions.
Okay, sorry, I double-barreled there, but
let's start with the emotions.
Yes, okay.
So many people are just confident that a computer couldn't have emotions, right? Emotions are something special about squidgy stuff. But suppose I take your brain and I replace one of the neurons by a little piece of nanotechnology that behaves exactly the same way as far as the other neurons are concerned. Okay. Every time this first neuron would have got ping and sent the ping to other neurons, this new piece of nanotechnology will go ping in the same circumstances. Okay? If you were conscious before and had emotions before, you're still conscious, you still have emotions, right?
Right, of course.
Now I replace the next neuron, and the next one, and the next one.
Right.
Until I've replaced all the neurons.
And then they connect.
The whole brain behaves the same way. So, of course, this little piece of nanotechnology have to be sensitive to chemicals in the bloodstream and stuff like that. Now you've still got emotions. So you don't have to be made of carbon to have emotions. That's the first thing to establish.
Right.
The second thing is an emotion has two aspects. This goes back to William James. There's the cognitive aspect of an emotion, and then there's a physiological aspect. So when you get embarrassed, your face goes red. That's the physiological aspect, and your skin sweats and so on. But also cognitive things happen, like you try and avoid that situation in future, and you hope your friends didn't see you getting embarrassed and stuff like that. Machines can have all that. They won't have the physiological aspects, but a machine can certainly get in a situation where it's embarrassed and tries to avoid that situation in future. So there's no reason it can't have all the cognitive aspects of emotions.
That's wild to think about, that it could be embarrassed. I can't understand that, yeah.
Well, why not?
Yeah, well, it's a machine.
Let's take something more obvious.
Okay.
Could it be frustrated? So I actually saw an AI system in 1973, that got frustrated and then got angry. It was a robot gripper, and on the tabletop you put the parts of a little wooden car.
Right.
Computer vision was very bad then, so you had a sort of green felt, and you put the parts of the wooden car on it, and the robot gripper assembled the car very, very slowly. But if you put the parts in a pile, it looked at them and it couldn't figure out what was going on. So it went bang and scattered them across the felt, and then it could see what was going on.
Wow, and that was in the 70s.
That was programmed in, but the behavior was like the behavior of something that got frustrated and then cross.
Right. I really wonder what my ChatGPT is saying behind my back. Yeah,
Probably best you didn't know.
Yeah, maybe. Yeah, it's definitely frustrated, for sure. Let's go to some audience questions. There seems to be an alignment gap between rapidly evolving technologies and our shifting moral values. If our ethical frameworks keep changing, how should we approach such problems in a way that isn't rigid? Do we need more philosopher engineers?
Okay, so you know what politicians do when they don't like a question?
They answer a different question.
They answer a different
question.
Know. So what I'm going to do is I'm going to ignore the first half of the question and just focus on, do we need more philosopher engineers?
Okay.
And I think we do. That is, I think the situation we're in now is like the situation people were in before they had sailing boats that could go long distances. They believed the Earth was flat.
Right.
And you can get away with believing the Earth's flat until you get boats that can sail off the edge, and then that won't work anymore. I think that's where we're at with AI. We have theories of what the mind is and how it works that we can get away with because we couldn't actually build minds. Now we can actually build minds, and these philosophical ideas about what the mind is and how it works won't work anymore. And it's engineers who are going to have to come up with better philosophical theories. The philosophers have been at it for thousands of years.
Right.
It's engineers, people who build things, who are going to have to come up with what the mind really is and how it really works.
Okay, let's go to this next one. You touched on the difference between You touched on the difference between what's happening in the West and the East. We hear about the global AI race. What are your views on the models and applications we're building in the Western Hemisphere versus what's being developed in the East? Are the goals and aims behind the AI research and development the same?
Okay, roughly I think the goals are the same. The countries are out to get a lead in AI, and the companies are out to make profits from AI. There's different applications they focus on. The Chinese are very interested in surveillance. The Chinese have access to lots and lots of data about people, more than in the West.
So does somebody in the States too, right?
One big difference is that the leading companies in the West are mostly don't reveal the weights of their models. Now, I personally think it's a big mistake to have open weight models. They refer to them as open source models.
Right.
But they're really open weight models. In an open source computer code, that's good, because people can look at the code and say, look, there's a security flaw there, or this isn't doing what you think it's doing. Mm-hmm. That's not what you do with open weight models. You don't look at the weights and say, that one's a bit too big. What you do is you retrain it.
Right.
So if you ask, why don't lots of little countries have nuclear bombs? It's because it's hard to get your hands on fissile material. And fissile material is expensive to produce. What's the equivalent for AI? Well, the equivalent for AI is the weights of a foundation model. It costs like hundreds of millions of dollars or more to train a big foundation model on a lot of data. And you get these weights, that's where all the knowledge is. And most of the big companies keep those weights secret for good reason. If you reveal those weights, now people with far less resources can take those models and train them to do bad things.
Right.
So cyber criminals can train them. Facebook actually released the weights of llama. It wasn't clear it was deliberate, but they made a feature of it afterwards. And I think that's a very bad thing to do. The Chinese are now using open source models. And of course, if you produce an open source model, many other people are going to use it. So you get a competitive advantage of people using your model and building on it because they can retrain it to do other things. And they can use it to make predictions and then distill other models from those predictions. So I think it's a mistake to release the weights, but it's been done already. They're out there now. And one big difference between the West and China is China seems to be focusing on open weight models like DeepSeek.
Right.
And the West still is mainly focused on, for the biggest models, they're closed weight. I think closed weight is sensible. Some of my academic colleagues disagree because, of course, a closed weight model they can't get their hands on to play with.
Right, of course.
But then nor can the cyber criminals. So I think that's probably the biggest difference, the focus on open weight versus closed weight.
Okay. I don't want you to paint a picture in terms of what's the worst case scenario, because I'm actually scared to hear it. But if we get this right, let's go there. If we do get this right, what could that look like? What could be the benefit here?
So if we get it right, we should get a massive increase in productivity,
okay,
which should mean there's lots more goods and services for everybody. We have to work less hard. We don't have to do boring work, all that's done for us.
Right.
We can focus on doing the things we like most. I suspect that when we have super intelligent AI, the only system that's going to be stable is where it's our mother and we're the babies, because that's a system in which less intelligent things control more intelligent things. If we can build maternal instincts into super intelligent AI, it will care about us more than it cares about itself. We need to figure out how to get that in there.
Is it starting? Are people doing it?
Not really, and I think that's one of the great hopes. There may be other ways to do it, but that's the only way I can see at present that we can coexist with superintelligent AI that has its own intentions. We have to make it care about us more than it cares about itself. And then it'll be like a mother with a child who's not very smart, who wants the best for that child and tries to make the child realize their full potential,
right,
even though it's much less than the potential of the mother. That might be a nice outcome for us.
That's a really interesting way to look at it, like that care that it would have for us. Yeah. Hopefully that's the best case
That's
scenario.
not how the leaders of the big tech companies look at it. They look at it as, I'm the
doubt they
CEO, you're my very smart secretary, who I can fire any time. Yeah. I say, let's make the company do this, you make it work, and I take the credit.
And this is, I think, what the disconnect is for me, like the intention from these companies. Like these guys are going to be leading these companies. They're the ones who have all the power. We see them at these tables with Trump. Like, so why would they even do this? How would they be convinced?
Well, they wouldn't.
Yeah.
That's the problem. You can't see Elon Musk or Mark Zuckerberg wanting to be the baby.
Very good point. We only have a few seconds left, and I'm seeing so many students in the crowd, and I have children of my own. I mean, what do you say? What do you say to the young people out there who are listening to this and are worried, and rightfully worried about the future?
I guess one thing I can say is, when you get an education, don't focus on a specific skill.
Okay.
Get an education in that encourages you to be able to think.
Huh. That gives you those critical thinking
Because specific
skills
are going to be taken over by AI.
Okay. Professor Hinton, it is always a pleasure, and I really thank you for your insight.
Thank you for your question.
And your patience. I'm going to turn it over to Richard Phillips once again.
You've been an amazing audience for 3 nights here in Toronto, and thousands of you from all over the world tuning into these Hinton Lectures. We've seen that over the last year, the pace of the development of powerful AI systems has moved faster and faster since we did this last year, and the importance of moving AI safety quickly along to address the challenges. And by the time of next year's lectures in the fall of 2026, we're going to see even more advancements and faster advancements in the technology and the models, and we'll need to be updated and make sure that AI safety matters are front and center more and more. There's no more important time to be engaged. So you've been amazing. Thanks so much for caring, and we look forward to seeing you next year.